part 2 of the angles in standard position. We're looking at this sheet, the drawing radian angles in standard position. And at some point, I know you're going to cut me off, and you'll probably do some of this in class, and that's kind of the plan. So that's great. The part A of this little investigation sheet story thing is about reference angles. I can't remember what the book uses, whether it uses the terminology reference angle or related acute angles. I'll usually use this, the RA, related acute angle, RA. The acute angle created between the terminal arm of an angle and the x-axis is called the reference angle, or the related acute angle. Here, the angle is 200, so that angle there is 200, and the RA is the little piece that goes over the x-axis, which is 20. So the RA is 20. The related acute angle is 20. It says state and sketch all the angles between 0 and 360 with a RA of 120. This is kind of review. We talked about reference angles and rotation angles in grade 11. So if I have a reference angle in the first quadrant, there it is right there, then that angle right here, that's actually 20. So that angle is 20 degrees. The second one is in the second quadrant. Remember, we label the quadrants in a circle, around in which way we rotate. So this is first quadrant, second quadrant, third quadrant, and fourth quadrant, and that makes sense because that's the way we rotate, right? So first quadrant, second quadrant, third quadrant, fourth quadrant, and so now if I have a related acute angle of 20 in the second quadrant here, that's 20, and it's always to the x-axis, then this is my angle theta. And what angle am I talking about? Well, it's 180 minus 20. 180 minus 20 is 160 degrees. And similarly, while this one was in the third quadrant, so now I'm talking about all the way into the fourth quadrant, first quadrant, second quadrant, third. There's the fourth quadrant. This is 20. And my angle is all the way around. Well, it's almost all the way around. Theta is 360, subtract the related acute angle of 20, which is 340. Well, dandy. Okay, drawing radian angles in standard position. So here it asked me to sketch each angle. This was easy when we knew radian, when it was in degrees, because we knew the cutoffs. This was 90 degrees, this was 180, this was 270, and this was 360 all the way around. But it's kind of hard to know the cutoff points, right? Well, hopefully you got somewhere along the line that this 90 is actually in radians is, I think we had this for homework last night, is pi over 2, which is about 1.57 radians, right? And instead of 180, this is pi, which is 3.14. And so notice that 2.2 is more than pi over 2. It's more than this, but it's less than this. So this angle, this rotation angle, is going to fall in this quadrant. This is theta here. It's 2.2. But of course, what's the reference angle? Well, how much is this right here? I don't know what the reference angle is. Well, the reference angle here, the RA, isn't 180 minus 2.2 because 180 is in degrees. It's pi subtract 2.2. And that's because this cutoff line, what was 180 in degrees, is pi in radians. 180 pi minus 2.2 gives you approximately 0.94 radians. So this little angle here is 0.94 radians. 7 radians. Okay, well, we know that this one was 1.57. This was 3.14. How much was the next one? Well, it's almost like I can. This is 270, which is, I think this was from homework last night. Again, this is 3 pi over 2, which is approximately 4 point something, 4.7-ish. and then all the way around, which is 362 pi, is 6.28, right? 2 pi, and then so it's this 7 radians is all the way around plus a little bit more. But notice I should say 2 pi. It's not all the way past this one, because this would, the second lap around would be another pi over 2, which would be almost 8 radians. So I know it's somewhere in the first quadrant, one spin around. Right? So how do I figure out, I'm going to label that before I go on. There's theta, which is 7 radians. So what's the related acute angle? What's this little bit in here? How would I figure that out? Well, I know it's going to be 7 radians, subtract the 1 spin. Well, the related acute angle, 7 radians, subtract the 1 spin around is 2 times pi, which is about 0.72 radians. Right? Same thing that we would do if it was in degrees, but we don't want to be going back and forth to degrees anymore. We can deal with radians. And essentially that's the goal of today's lesson. I think that you can do this one on your own. I will take this up. The idea is just counting by 30, but since 30 is pi over 6, when I'm counting by 30 degrees, I'm actually counting by pi over 6 radians. And so I fill this in. This is 3 pi over 6, and then 4 pi over 6, and 5 pi over 6, and you write this all down. But put it in lowest terms. Notice pi over 6 is already in lowest terms, but here I can cancel, right? 2 goes into itself once and into 6 3 times. That's actually pi over 3. And so I'm counting by pi over 3. And I can fill this in. Now what do I want for part, and you're going to fill this in a second once I explain the rest. It says sketch the series of angles labeling the terminal arms. Well, there's 0 radians. The next one would be 30 degrees, but we don't want to think in degrees. We want to think in radians. So here it would be an angle of, this one is pi over 6. This tiny little angle is pi over 6. And then the next one would be, in degrees we'd think of it as 60, but the next one is pi over 3, right? That's pi over 3, or 2 pi over 6s. And then another one, even though this isn't exact, would be whatever this is. Well, 3 pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, but that is pi over 2. And in fact, dealing with angles in radians is actually just dealing with fractions. Okay, I think that's where you should stop. Try the next few exercises, exercise 3, and the next few exercises, exercise number 1, number 2, number 3, and then I'll show you my answers. You can pick that up in class. There are a couple of examples after, but actually I think I'll do that in a part 3 of this lesson. You can stop there and pick it up in class.